Hello and welcome to XMed Education. Please subscribe to our channel on YouTube and follow us on Instagram. Let's start. In this video, we're gonna talk about the organization of the circulatory system. So, what do we mean by that? So first we need to know the function of the circulatory system. They have many functions. First, transporting nutrition, waste product and hormones so they can help endocrine system to transport hormones. Second, they have a role in thermoregulation. It means that they keep our body warm. The third function is defending body by white blood cells so they can check everything during the circulation on the road. The circulatory system is divided into the arterial system, venous system and microcirculation. So blood go to the artery, then capillaries and then veins and go back to the heart again. So now let's talk about the component of the circulatory system. The circulatory system divided to the systemic circulation, pulmonary circulation and our heart. And most of the blood is inside the systemic circulation. As you can see, 64% of the blood is inside the venous system. So blood from the heart goes to the aorta, then arteries, then arterioles, then capillaries, then venules, then veins, and then vena cava and go back to the heart again. And from that they go to the pulmonary circulation for oxygenating blood. Vessels have elastic tissue and smooth muscle, and that's really important. However, capillaries, they don't have these two tissue. Elastic tissue in the aorta is the most, and in the arterioles has the least number, and in the smooth muscle is opposite side. Arterioles has the most smooth muscle and aorta has the least smooth muscle. That is really important in case of the resistance that we're gonna explain in our future slide. Most cross-section area in the body are the capillaries, and they are 2500 square centimeter in case of the vessels. Hemodynamics. Now let's talk about some physics things. In simple word, it means how blood flow through the circulatory system. So there are some physics laws as we talk about the flow, but they are easy, don't worry about them. First, pressure and flow are not constant. That's why we have pulse thanks to our heart. Second, in blood, viscosity is not constant. And third, vessel wall are elastic. We're gonna talk about them in more details, but let's start talking about the velocity of bloodstream. So what do we mean by that? Velocity is equal to the distance per unit of time, and it's a basic physics things. The second thing is flow, is that the rate of displacement of volume of fluid, and it has its own unit as well. So look at this equation. V equals to the flow over the time. So look at this graph for better understanding. As you see, flow is constant through all the vessels, but the area and velocity change. So if the diameter is like 10 centimeter, which is big, velocity is 1, and if the area is 1 centimeter like capillaries, the velocity is high. But as I explained, capillaries has the most cross section, so it means that they are bigger. Velocity decrease as blood flow through the arterial system, and velocity is minimum at the capillaries because they have the largest cross section area. As the flow go back to the venous system, again the velocity increase. The relationship between the velocity and pressure that we call it Bernoulli's equation. The total pressure in hydrolytic system depend on three factors: pressure, gravity, and velocity. But you have to understand that the total pressure is equal in different segments of the tube in the ideal situation. So total pressure, which is constant, is equal to the static pressure, dynamic pressure, and hydrostatic pressure. And dynamic pressure dependent on the density and velocity. Density and velocity. It is really important to know that. So in conclusion, in a narrow vessel, which diameter is low, the velocity and so on, the dynamic pressure are greater than in the wider vessels. So if the total energy is constant through the vessels, the pressure in narrow vessels will be less than pressure in the wider vessels. So let's look at the equation one more time for better understanding. When the total pressure is constant and velocity increase, dynamic pressure increase. So dynamic pressure increase, total is constant, so static pressure will decrease. And why is this important, and why should we know that? Pressure changes in a vessel that is narrow by atherosclerosis or spasm, which means narrowing section of the vessel. So the dynamic pressure will increase and static pressure decrease, which means lower blood supply go to that region. That's why the patient gonna have chest pain or angina in case of myocardial infarction or heart attack. So velocity increase, dynamic pressure increase in case of atherosclerosis, but the total pressure is constant, so static pressure decrease, and it means that lower blood supply goes to that region. And this graph explains why this Bernoulli's laws is important. Now let's talk about the determination of blood flow. What do we mean by determination of blood flow? Flow increase as the pressure gradient increase, flow decrease as either viscosity of fluid or the length of vessel increase. For that, look at the equation of the flow. Flow related to the diameter or radius, so diameter increase, flow increase, and viscosity increase, flow decrease, and length increase, flow decrease. So you don't need to know the equation, but you need to know the features and relationship between different things. So now let's talk about the resistance to the flow. We have Ohm laws in physics that all of you guys are familiar with, but like in our vessels, we talk about the difference between pressure divided by the flow will be equal to the resistance. I explained about it when I was explaining about the total peripheral resistance in our previous lecture. Look at this feature of the resistance. Resistance is equal inversely related to the radius, and radius to the power of 4. So it has a huge effect on our resistance. So if radius increase, there is a huge effect on resistance. So resistance to flow is inversely proportional radius of the blood vessel. The most important factor that leads to change in vessel diameter is contraction of the circulatory smooth muscle cell in the vessel wall. So change in internal pressure can alter the diameter. Blood vessels are elastic, so the greater the difference between the internal and external pressure, the greater the diameter of the vessel is. So series and parallel resistance. When we go from the aorta to the artery to the arteriolar or capillary venous vein, there will be a series type of resistance, and the total resistance is equal to the sum of them. But when we look at the resistance from organ to another organ, for example, some vessels go to the brain, some vessels go to the heart, to the kidney, the total pressure is inversely related to them, as you can see in the picture and in the equation. So it depends on if we mean series, it's artery to arterioles, and parallel we talked. Laminar and turbulent flow. So what do we mean by that? In laminar flow, velocity of blood flow highest in center of the vessel and lowest close to the vessel wall. So close to the wall is around 0, and in center it's a maximum. It's a good thing. In turbulent flow, which means that there is something pathological, more energy or pressure is required to drive turbulent flow. It has an audible vibration called murmur, and it's a bad thing. This is what happens when valves in the heart have a problem, and you can see the graph and all I explained. As you see, laminar is very in a good direction. Reynolds number is a number used to predict the transition between the laminar and turbulent flow. So from 0 to 2,000 is laminar, 2,000 to 3,000 is transitional, and 3,000 above is turbulent. So this number is really important. Please memorize it. And the other thing that we need to talk is wall tension. Wall tension is the difference between the pressure of the inside the artery and outside the artery divided by the radius of the vessel. Vessel distensibility means that if the pressure increase, volume will increase, and when are the more distensible vessels inside our body, and they depend on the compliance. So compliance allow vessel to increase the volume, and compliance of the vein is much more than compliance of the artery and pulmonary vessels and systematic vessels. As you can see in the graph, compliance is equal to the slope of pressure volume curve. You can see that in the vena cava the slope is very vertical, but in the aorta the slope is less than less than compared to the vena cava, and they have a different in case of that. So in total you need to know these two graphs and how the compliance inside the vein and inside the arterial system, and because of that the 64% of the blood is inside the vein, and they can save blood for different situations such as shock and when there is not enough blood inside our body. Thank you.